Alright, in this video I'm going to show you 4 of the practice problems. You need to do page 403, number 1 through 12, and there is room on the handout that I gave you along with the guided notes. There's space for you to do it there, and I will be going through number 1, number 5, number 8, and number 9, and then you will complete the others on your own. Here we go. Number 1 is to identify the domain and range of each function. And I think the first 3 problems are like this. So what I'm going to do is I will always start with my domain. So the domain, remember, I need to figure out what I don't want, what can't be negative, and that's what's inside the square root sign. So basically 4x must be greater than or equal to 0. It can be equal to 0 because I can take the square root of 0. So if I divide both sides by 4, I just get x is greater than or equal to 0. So the domain, and I will write it in set builder notation, is x such that x is greater than or equal to 0. And there's my domain. Range. Now what I'm going to do to find my range is I'm going to take this value, this boundary for the domain, 0 for x, and I'm going to put it into the function. So the f of 0 equals the square root of 4 times 0. Well, that's going to be 0, so the f of 0 equals 0. And so range, again, I'll write it in set builder notation, f of x such that the f of x is greater than or equal to 0. And that's how you will do domain and range for the next couple of problems. Next, let's look at number 5. I'm finding the domain and range, and I'm also graphing. And so let's talk about a few things here. Remember, we had that kind of base equation that y equals, or f of x equals, a times the square root of x minus h plus k. And h is the horizontal shift. In this case, h is 1, right? Because the minus matches the minus, so h is actually 1, which tells me what I'm going to have is a horizontal shift to the right from my parent function. And a being 3 lets me know that my graph is going to stretch vertically because a is greater than 1. So let me show you that with the domain. There's a few ways that you can do this to start your graph. So my domain, again, I know that x minus 1 has to be greater than or equal to 0. So x has to be greater than or equal to 1. So I'll write my domain x such that x is greater than or equal to 1. And that's really my boundary. That's my starting point, right? And next I'm going to do my range. So I'm going to put in 1 for x. So I have the f of 1 equals 3 times the quantity square root 1 minus 1. Well, this inside here is just 0, and anything times 0 is 0. So the f of 1 equals 0. So the range in this case, the f of x, is f of x such that the f of x is greater than or equal to 0. So just what I thought, this first point is going to be at 1, 0. So my graph has shifted to the right one, just like I thought it would. So this is going to be my starting point right here. Okay? And then what I can do to get some other points so that I can graph this, I can just do a table of values. So I'm going to do x and f of x. So I know that when x is 1, f of x is 0. Now what I want to do to make it easier on myself, since I'm taking a square root, I want what's under the square root sign to be perfect squares. That will make things quite a bit easier for me, right? So if I just think about listing my perfect squares, 0 is the first one. That's our starting point. Then 1, then 4, then 9. So I want x minus 1 to equal these things. So if I put in 2 for my x, that would give me 3 times the square root of 2 minus 1. Well, 2 minus 1 is 1, a perfect square. Its square root is 1. And then the f of x is 3. The next one I would want it to be equal to is 4. So if I put in 5 for x, that would give me 3 times the square root of 5 minus 1. This is 4. The square root of that is 2, so 3 times 2 is 6. So now I have a few points to graph. So I've got my first one, my starting point. Now I'm going to go to 2, 3, and then 5, 6. And then I will draw my graph from there. Sorry, that's not the best on this little pad. It's kind of hard to draw those. Sorry about that. So as we can see, the 3 stretched it vertically, right? It stretched it vertically. Okay, so and I already did my domain and my range. Here's my domain and here's my range, and that helped me with my graph. Okay, number 8 is a word problem, your favorite. So I've copied it here, and you don't have to graph this one to answer the question, but I'm doing it because I want you to look at how you can analyze the graphs of square root functions in word problems and help you to see if the solution that you're coming up with is actually a reasonable solution. So the speed that the tsunami or tidal wave can travel is modeled by this equation here, v equals the 356 times the square root of d. V is the speed in kilometers per hour, and that I have put on my y-axis. And then d is the average depth, and I've put that on my x-axis. A tsunami is found to be traveling at 145 kilometers per hour, so that the speed in kilometers per hour is v. What's the average depth of the water? So basically we want to find out what is d when v is 145, and then we're told to round to the nearest hundredth of a kilometer. So I'm going to show you this both graphically and algebraically. Graphically will get us an idea of reasonableness, and then when we do our algebra we'll know if we've done it right based on our graph so that we can analyze things. Okay, so when I do this, based on this equation, when d is 0, so I'm just going to do my table of values, d and v. When d is 0, v is 0. And that's going to be my starting point, right? Because what's under the square root is just d, so that's 0, and I don't want it to be negative. So there's my starting point, 0, 0. And it makes sense that when you haven't gone any depth, there's no speed and no depth at the same time. So there's going to be my starting point. And then next what I'm going to do on this one, this 356 is quite a large number, and the 145, see if I put in 1 for d, I'll show you that now. I'm going to put in 1 for d. Square root of d is 1 times 356. That is more than double the 145 kilometers per hour, because remember this is, I want 145 in there. So I'm going to actually use some fractions for d. And I want to use fractions that it will be easy to find their square root. So if I put in 1/9, what that's going to be, if I put in 1/9, is 356 times the square root of 1/9. Well, the square root of 1/9 is 1/3, so I just divide 356 by 3, and in decimal form that's going to give me 118.7. And then the next one I'm going to use is 1/4, because again, that's easy to find its square root. That's going to give me 356 times the square root of 1/4. Well, the square root of 1/4 is 1/2, so I divide 356 in 2, and that'll give me 178. So I'm going to graph these points that I have here. So I already did 0, 0. I'll do the point where d is 1 last. 1/9. That's about halfway between 0 and 1/4. It's a little more than halfway, and it should be the v value at 118.7. So I'm going to put it about right here. It's approximate, okay? And then at 1/4, it's all the way up at 178, which is about right here. And then at 1, it was all the way up at 356, which is just above right here. So we can see that the 356 has really stretched it vertically. And now I will draw this the best I can. Again, it's a little, it's hard to get it smooth on here, and for that I apologize. There we go. That does not taper off that fast. It should go up higher. But there's the arrow. So what I was asked was, a tsunami is found traveling at 145 kilometers per hour. What's the average depth? So 145 is about right here, okay? So I know a reasonable answer cannot be bigger than 0.14, or I'm sorry, 1/4, which is 0.25. I know that it cannot be bigger than 0.25, okay? it would not make sense if it were larger than 1/4 of a kilometer, because based on the graph, that's just not possible. So do you see how graphing can help you determine reasonableness of an answer? And I can see if I just did, these points I've got, because it's really also between these 2 points, it's going to be between 1/9 and 1/4. Well, 1/9 in decimal form is 0.1, right? And 1/4 is 0.25. So my answer has to be between these two. So I'm going to say V is 145 equals 356 times the square root of D. I'll divide both sides by 356 to start isolating my D. It's just straight algebra. Now, to get rid of the square root sign, I have to do the inverse operation, which is to square both sides. So I need to square both of those. And so now here's where you do your handy-dandy calculator magic. You'll do 145 divided by 356, and then you square the result, and you're rounding to the nearest hundredth. So the depth when the tsunami is traveling 145 kilometers per hour, the depth will be 0.17 kilometers. And that is a reasonable answer because I can see that that's between 0.1 and 0.25. So the answer actually makes sense. That's how we analyze graphs. Okay, the final one is to graph an inequality. I didn't have this in the other video because we know how to graph inequalities, and now we've talked about how to graph square root functions. So it's just putting that together. So let's look at how we're going to do this. All right, so step 1 in graphing our inequality, we're going to graph it as an equality, right, to get our base graph. And in this situation, because I have an equal sign, that means my graph is going to be a solid line. And I do want to check that because I need to know if my graph should be solid or dashed, and it's solid. So I'm going to just start making an XY table. Okay, so when x is 0, because I want this to not be negative, what's the amount that makes this just above negative? That's 0, and then y would be 4, which makes sense. I should have a shift of my graph 4 to the right. Okay, and now I'm going to put perfect squares in here. So if I put in 1, the square root of that is 1, square root of 1 plus 4, that's going to give me 5. My next perfect square is 4, so I have the square root of 4 plus 4, well that's 2 plus 4, so that gives me 6. Okay, so I now have a few points so that I can do step 1, which is graphing. So I'm going to start at 0, 4, and then I go to 1, 5, and 4, 6. And I draw my graph. I draw my line. And again, I think I evened it out a little too, I made it flat a little too early. It probably should go up a little bit more there. Okay, and then we need to do the shading. So that's going to be step 2. So I need to check out my domain on my shading, because the difference here isn't it's just above and below. That's part of it, but I need to make sure it falls within my domain. The up and either shading above the line or below the line, that's about the range. I need to check the domain. So the domain on this situation is x such that x is greater than 0. So my shading cannot be, so that means everything to the right of the y-axis all over here. My shading cannot be on the left side of the graph, okay? And because it's greater than, my shading will be above. So my shading goes here, but it cannot go to the left of the y-axis because x has a restriction where it cannot be less than 0. All right, go ahead and finish up the practice problems and then do the Google form. Once you submit the Google form, there will be a pop-up with a link in it, and when you click on that link, it will give you all the answers to the sample problems, so you'll be able to check all of your work before you come into class. Good luck.